Hello, everyone, and welcome to this Learn Live session. I am Geraldine Cazzo, a data and AI senior cloud solution architect at Microsoft with a number of years of experience in anything data. And today I'm joined by my colleague, Goran.
Hi, everybody. My name is Goran. I am also a cloud solution architect for data and AI based out in Germany, and I'm happy to be presenting for you today.
Thank you, Goran, for that. So we also are going to be accompanied by our principal technical specialist who is Inder Rana, who's going to be a moderator. Please say hi to Inder. He is going to take over the communications. He's going to chat with you. Please, this is a very interactive session, so send all your questions to him, and Inder will be able to answer all of them. And if there are some that he wants us to answer, then he will bring it to our attention too. So please say hi to Inder Rana, and please make sure to make the session more interactive. So if you have not been to a Learn Live session earlier, and this is your first Learn Live, this is based off of the free Learn modules that we have at Microsoft. And you can follow along with us at the aka.ms/learnlive with today's date. It has like an interactive learning exercises. They have the content also is available there, so you can practice along with us, or you can do it in your own time. But it's a good thing to get started with, or at least follow along with us for the initial set. So today we're going to talk about the Azure Cosmos DB for PostgreSQL, and in particular, we're going to talk about managing performance and availability. So, Goran, do you want to talk about what Azure Cosmos DB for PostgreSQL is before we delve into the details?
Yes, absolutely. Azure Cosmos DB for PostgreSQL, quite a long name for a database, is one of several database services in the Azure cloud. And this specific flavor is essentially a managed service for PostgreSQL extended with a Citus open source extension, which allows for distributed Postgres databases based on clusters containing multiple nodes.
Thank you for that, Goran. So now that we know what Azure Cosmos DB for PostgreSQL is, I'm just going to talk about what Goran and I are going to cover today, because as you know, there are multiple modules in with Azure Cosmos DB for PostgreSQL, the Learn module. But we are going to talk about the scale and the rebalancing of data in the Azure Cosmos DB. This is to be enable you to accommodate any data growth that you have. We're also going to talk about read replicas so that you can address your analytical demands and your read-only workloads. And last but not least, we're going to talk about the high availability to ensure that data is available for the users who need it. So with this in mind, we thought the better way to do this is to talk about a use case and walk through the use case, look at what the requirements are for this use case, and see how these particular objectives and features of Azure Cosmos DB for PostgreSQL, how it fits in with it. So we have a use case where we're working with the database DBAs for a Woodgrove Bank, and they have an app which is the contactless payment app. Now, this app, they want to expand. They have it right now, and they want to expand it to other areas in the US as well as across the seas to Europe. And they want to use Azure Cosmos DB for PostgreSQL. But they have their own set of criteria and requirements. So let's just go through that and see what we can do. So the requirements that they have is the ability to expand the app to customers across Europe and the USA. And they want to be able to have the app handle any increase in usage especially during the shopping seasons. Then they also have their European corporate offices, and they want to offload their reporting and analysis workloads to the European corporate offices. And the third thing that they want is the ability for all their users to be able to access that application any time of the day. As you know, it's a contactless payment applications, and all of you have used payment applications. This is crucial, is that you have the ability to use it whenever needed. So, Goran, let's talk about how we can use the scale and the rebalance in the Azure Cosmos DB for PostgreSQL to help them, especially when they have their biggest shopping season, because not only are they expanding the users, but now during the shopping season, you know that there's going to be bursts in traffic. They're going to have a lot of transactions come through. And so it needs to be processed and they need to have more compute power. So, in order for us to be able to achieve or meet this requirement of theirs, what do you think? How do you think the scaling of compute and storage will help them? Will it help them?
Absolutely, that's the main point of this particular database service that we are talking about. If we compare this flavor of PostgreSQL just for a moment with a normal single PostgreSQL server, the difference is that with this setup, with this architecture, a database will be distributed across multiple nodes. If you look at this screen, this is the simplest possible architecture of a Azure Cosmos DB for Postgres that consists of exactly 3 single Postgres servers. We need to understand their roles. One Postgres server is always in the role of the coordinator, and its only purpose is to coordinate the remaining nodes. All other nodes are worker nodes. That's the servers that actually execute our queries, our workloads. It's important to understand that each of these 3 instances are for themselves one complete standalone PostgreSQL server. So a Cosmos DB for Postgres cluster consists of at least 2 of these, or of at least consists of at least from 3 single nodes. One is coordinator, the other 2 are workers. Now, what about scaling? Scaling comes in 2 flavors.
Yeah.
The one is called horizontal scaling and the other vertical scaling. What does it mean? Is follows. Horizontal scaling means that we add 1 or more additional nodes to the cluster, thus stretching or distributing our database across more and more nodes. All these nodes have identical structure, same number of processors, same amount of memory, same storage, but by adding more and more of them, we can allow for bigger databases and for big amount of data for bigger workloads. That's the horizontal scaling. The other type of scaling is called vertical, and it doesn't include adding any new nodes, but it means increasing the amount of available resources in each of existing nodes. In other words, it means increasing number of processor cores, of amount of memory, amount of storage, etc., etc. Both of these options are supported. They can also be combined, and then they have certain purposes and roles.
Okay, so that's a good point, because they can use both. They can use the vertical scaling as well as the horizontal scaling. I think the horizontal scaling will work when they're trying to add more users and add more customers, and then they can add the nodes whenever they need it. Whereas when they have the shopping season and they need more CPU or more resources, then what they can do is scale vertically and increase CPU and storage when when they have the need for it, or when there is a burst or a spike in their processing. And then when it goes back to normal and the shopping season is over, then they can scale back. So
Correct.
here's how you can scale the compute and the storage for your worker nodes. Now remember that you're scaling it for each worker node, and you can scale the vcores and the storage. Both are scaled independently. You don't have to increase storage if you want more processing power, and you do not need to increase the CPUs if you need more storage. These are separate and they can be scaled separately, which is a good thing. But what you need to know is that if you scaled it for one node, it's going to be scaled across all the worker nodes that you have. As you can see on the screen, and we will do this later in the demo, you have the worker node, you specified how many worker nodes you needed. And then when you have the configuration, you have the vcores and the storage. What do you think is missing from this? What else is a resource that you think is required? So you have memory, right? Memory is also one of the resources that you need. But you have to remember that memory goes along with vcores. So if you need more memory, that's not enough, and you have 4 vcores, you'll have to go to the next level, which is 8 vcores, because they are not separated like the way vcores are from the storage. So as Goran mentioned, if you want, now let's say you've got two cores, like 2 worker nodes, and now you have more users and you need to now increase it. So what would you do, Goran, if they have to increase the number of nodes? How easy is it to increase it?
Adding additional nodes is pretty easy. It's a matter of a couple of clicks in the Azure portal. We can increase, by 1, 2, or 3, or any other number of nodes, and that's really all that user needs to do. The rest of the configuration happens automatically behind the scenes by the platform. And as soon as the additional nodes are provisioned, they are part of the cluster, and the user can take the next step.
Okay, so once they need to add the worker nodes, let's say they go in and then they just increase the node count. Let's say I started out with 2 nodes and now I've increased the node count. It's pretty easy to go in. As you can see, you can go into scale, and from scale you increase the nodes and say, okay, I want 3 nodes now or 4 nodes now, and then you specify what the compute and the storage needs to be, and that's how you save it, and then automatically the worker nodes are increased. Now, what happens though? You already have your data that was sitting on 2 nodes. So what happens to the third node? As soon as the third node is provisioned or added to your cluster, what's going to happen? How will I get the data across? Do I need to manually copy it over?
Right, that's a very important point. It's important to remember that just physically adding another node doesn't mean that our data will be automatically moved to this node. So this picture visualizes what happens immediately after an additional node has been provisioned. It is a part of the cluster, but at the first moment it's completely empty. So we as a user, we need to define which of the data will be moved across from the first 2 nodes to the new node, and how that will happen. There is also a SQL command which can be used to check the distribution of the data. It's shown on the next screen. It's pretty simple. We call it shard placement. By the way, shard is the term that we use for parts of our data that is stored on a certain node. We have one table, we distribute it across 3 nodes. Each of these 3 parts of our table is a shard. So this statement here gives us information about the sharding of our data and which shard is placed on which node. As a result of that, we can decide on how to redistribute the data again, and to bring a balance in our new hardware configuration.
And we can also know how whether the new node already has data or not, right? So we can easily go into the shard rebalancer, and when you go there, it displays the screen to you and it shows you whether you need to rebalance it or not. And it tells you, yes, rebalancing is recommended, which means that it has not been rebalanced and you would manually need to rebalance it so that your data is evenly distributed. And so there are two strategies by which you can do rebalance it. You have the shard count and the disk size. By default, we use the shard count, and it's whenever you run your rebalancing function, it rebalances it according to the shard count, but then you have the ability to also choose the disk size if you want your shards per disk size. So once it's rebalanced and it's ready to go, do we need to check it again to see whether it's rebalanced? And how do we do that? Do we go back to the shard rebalancer and just check it?
We can repeat either the SQL statement shown before, or just to look in the portal in the rebalancing recommendations. But after this statement is executed, then there will probably be no further recommendations for more rebalancing.
So once it's rebalanced, then the coordinator nodes knows which is the tables that are rebalanced. And just so that you know, the local tables and the metadata tables always are retained in the coordinator node. And the reference tables are on every shard, as well as the table that is distributed, right? So the distributed table will also be on the shards as redistributed across, and the reference table will be a copy of it will be made on each of the worker nodes. So I am going to now walk you through an exercise. So let's go to and if you want to follow along with me, you can. I'm going to open up the Learn module. As I mentioned in the first few minutes, that this is all based on the Learn module. As you can see, you have learn.microsoft.com. And all this information that we have, even in PowerPoint, is all present here. The content is here. The exercises are here. So now I'm just going to walk you through the exercises and how to create it. Now I've already created one and I have it ready to show you how to add a worker node, but I'm going to walk you through creating it. And while it's taking time to create it, I'll go back to the one that I've already created to show you how you can add a worker node, right? So if you go into the portal, let's go to create a resource and follow through. Let's just follow through. So here it says we're going to have one coordinator node and two worker nodes, right? So that's where I'm going in to create one coordinator node and two worker nodes with 4 cores and 0.5 TB of storage. So when you go in, let's go to the resources, or you can go into the databases, and I'm just going to look for Azure Cosmos DB for PostgreSQL. Okay, and as you see, it's brought it up here. So I'm going to go and say create. Okay. Let's say let's follow through. Let's put in the resource group as this. You can choose whatever you want, any resource group. So I'm going to create a new resource group. This already exists, so I'm going to just include the Learn Live. And let's see if it takes it. Okay, so that's there. Let's go back to the cluster name. Let's say this is what my cluster name is going to be within this resource. I'm going to choose East US because that's the closest. And now let's go back to the configuration. What did it ask us for? It said we needed 4 vcores, and what was the, let's go back and look at 4 vcores and 0.5, like so. Just let's go and create. I'm going to take 512 GB. Let's not worry about the availability zones. I'm going to go and create 2 nodes.
Geraldine, what do you say about a single node cluster?
Yes, so single node, you can create a single node, which is one node, and later on, when you have more requirements, then you can change it. The good part about this is right off the bat, you do not need to go to 2 nodes if you don't need it, but you create the cluster, you keep it ready. So just in case you need it later, then you can expand it. So you have to know whether you need the requirement, you need to expand it, and you need a cluster later. So then you can go with the single node as opposed to going with just the flexible server.
Okay, thanks.
So save that. And as you can see, the database name is Citus. The version is 15. I'm keeping it as is. The username is grayed out. It's Citus. Let me enter the password. Let's say okay. Let's see if I get it right again. Okay. Now let's go to network. Let's follow follow through here. Okay. So we've done that. I've used a different subscription. We followed this, we created it, we created the username. Now and I've already shown you that we've created 2 nodes. I took it as 512, 4 cores with 32 gig RAM. The coordinator node, let's go back and see if I put in, we'll come back to the coordinator node and I'll show you how to do that. So, because I don't think we went through it and I took the defaults that were there. So we'll come back and change the coordinator node also. And now once we're done with that and saved it, you can go back to the networking. But instead of that, just let me go back here and go back to basics. And then let's, okay, go to next. Let's go back here. So it says allow public access. I'm going to allow public access. In my case, I'd like to use, you can use a bash shell, but you can also use pgadmin, or you can use ADS, which is the Azure Data Studio, which you could use for SQL Server and for your other needs. So I'm just going to add my IP address so that I'll be able to access this cluster through my ADS. And ADS, like I told you, is the Azure. Let me just open it up. This is the Azure Data Studio. So let's go in there. There's nothing to encrypt. There's no tags. Let's do a review and create. Let's look at it and see what we have. Now the coordinator node, and I'll change it again. So let's go in, go to the scale. Okay. And let's just say create. So while that is creating, and it'll take some time, let's go back to the one that I already have. Okay, this is what happens. Let's go back here and see what the reason is. Deployment, let's go back to my resource group. Okay, what happened with my create? This is what happens when you do a live demo. Let's go back to my deployments and see your deployment failed. Okay, I'm going to quickly go back and the name is already in use. Okay, so let's go back to it and recreate it again. I'm going to recreate and refresh it, go back to my home, quickly create it. Let's do another Azure Cosmos DB for PostgreSQL. Okay, create it. Okay, I'm going to create new resource group. Let's go follow along. It should have told us ahead of time, so let me create this and say LL 1 to 3. Okay, and enter the cluster name. I'm going to say learn live 1 to 3 East US. Citus, enter the password. Okay, let's go previous, go back to configure here. Let's go to 2 nodes. What did they ask us for the 2 nodes? 4 core 512. Let's do 4 core 512. Let's go to the coordinator node. 4 core 16 RAM and 512. Okay, and we're just going to leave the high availability and save. Let's go to networking, public, allow public service from the other Azure resources. Let's add my client IP. Go back here. Okay, so we've got everything. And let's go to review and create, and let's keep our fingers crossed. Okay, let's look at it right now. So public access, yes, that was mandatory. So let's create. And while that's being done, I'm going to go in here and go to my Azure portal. Okay. I'm going to switch. Okay, I'm going to switch directory, switch it to my subscription that I have. Okay, as you can see, it's creating these resources, but I created one before, which is the Learn Live. So let me click on the Learn Live cluster that I've created earlier just to show you what it has. And you can see we have access to the resource group, the subscription, and the public access based on the connectivity that I've created. The coordinator node is 4 nodes. So if you go to the overview, it'll give you all the information that you need or you want to know about the cluster that you have created. Now I want to go into connection strings. And it's taking time to show me the. Okay, so let's go to Yeah, I want to see the connection string for this. Okay, I'm unable to pick it up, but let me go to my OneNote and see if I can have it there because it's not showing it to you, but this is what it is. As you can see, the host name, the port, it shows you what the DB names are, and then you need to specify or change your password. So I'm going to go here. It has it on. So let me go back here, and I need to change the password to this admin 12345. Give me a minute, let me check to see if I've got the password right. This is for the one that I created earlier. Yes, okay. So I'm just going to obfuscate that, and let me copy this from here. Let's go to the bash shell. Okay, let's follow through now. Let's go back here. So let's connect. So it will show you when I copied it, it was not displaying it, but I copied it and it gave me the exact SQL that was there. This is how it shows up. And then I'm going to the Cloud Shell and I'm going to run bash. When you choose it, if you do not have a storage, it'll ask you to create the storage. But I already have the storage, so I will use a storage that is already available. So let's go back here. Let's go to the Cloud Shell here. Like I said, I already had it, so I don't really need to get into it. So let's just paste. Okay. Okay, so as you can see, it has connected to PostgreSQL, and now we have the ability to run any of the select statements or anything here. I also want to show you in how you can do it through ADS. So in ADS, you can do a connection here. So let's say I want to have a new connection. Okay, so this is how you get the connection. You specify, as you can see, I have the extension in Azure Data Studio. So I just want to show you that there are different ways in which you can access this. So I put in PostgreSQL. You specify what the server name is. So as you can see, this is what the server name is. Control C. Put that in here. The username is Citus. I will put in the password. Hopefully I got the password right. The default name is Citus. And let's connect and see. And this is how it's connected. Okay, so now this is the same thing that we have here. I've connected to it, and that's how you connect to it. So once you connect to it, you create the payments table. So once the other cluster is created, then I can run and create the payments table. And this is how you run and show you how to distribute it and do a select count to show you what it has. This is what you're going to do once that it has been created. So I'm going to skip this for now and go to the add node just to show you how you can add the node. First, let's see, and then we'll come back and see if the cluster has been created. Then we can connect to it and run all these statements again. So let me go back to the live learn, and let's go back here and see. It's still saying that the deployment is in progress. So let's wait for that to progress. So, and then let's just go back to the learn live that we have here. And okay, so I'll go back here and show you. So let's say I'm creating a table, payment user 1. It created it successfully. Now select, I'm going to distribute the table. So this function allows you to now distribute the payment user 1 across the shards. So let's run it. It has no data right now, so I need to set the encoding to UTF-8. Let me just copy this. Let me see what's in here. I'm going to copy it to payment user 1. Okay. I'll go back now to the portal. And let me paste this here. And so now I'm going to copy data from a CSV file into this new table that was just created. Okay, let's see if anything was done here. Zero. So let's see. Let's do, okay. Go back, copy it. Okay. Let's paste it. I mean, we should have this because it was there yesterday. So now let's, it's not copying anything. So in the interest of time, and because I did this and I already have it, let's look at what's there in. So we have this many number of rows that already exists in the payment users, user 2. Let me do one more thing. I'm just going to copy this again. Okay, I'm just going to go. I'll copy it directly. Yeah. Okay, the resource is already there. So let's go back to ADS. Let's use the payment users now. And let's see the data, whether it has been distributed or not. So let's run this. So this is the node name that has not been distributed. Let's see what the default strategy is. As you can see, you have a false and a true. So it's using the shard count, whether it wants to do with the strategy, whether you want to use a shard count or a disk size. Those are the two strategies. And as I told you, the default strategy is the shard count. And then you can run this command to rebalance your coordinate, the data that you just copied in. Okay, and it shows you that everything is done. You don't need to rebalance it again. Now we can do the same thing with the new server that we have just provided, or provisioned rather. But let me go back now and go back to here and show you another scale and how to add a node, right? So let's just collapse this for now. And as you can see, I'm going to have, let's say I want 4 nodes. I'm going to increase it to 4 nodes. And with the same, I'm not going to scale it vertically. I'm just going to scale it horizontally. And then I'm going to save it. So let's go back to the Learn module. I'll just close this. Okay, the deployment is in progress, so it's adding another node. Let's go back here and see. So I showed you how you could create the table. So while that is adding, I'm going to go in here and do a new connection. With the new node. Go to your resource. It's taking a little time. Let's go back to connection. Let's copy this to clipboard. Let's take the host. Copy the host in ADS. This is the new, remember, this is the new one we just provisioned. Let's change PostgreSQL. Add this in here. Password. Username is Citus. How are we doing with time, Goran?
40 minutes.
Oh, okay.
Already.
So doing okay. All right, because this is the longest piece of it, and then I think we're good. Yep. Connect. Okay, it's connected. That's to the new query. Go back to the exercise. Let's now create this. Oh, I can go do it here. Okay, you did that. So let me go back to. Okay, so now let's select and see what it's doing. Just copy it. Go back to the learn mode. ADS. Run. Okay, there's nothing there. Go back. Now let's go load the data. Let's go to open up. First, I need to go to the PSQL and add it in here. So let me copy the password.
Perhaps just a comment while you're doing that, Geraldine. With the first SQL statement, we have just defined a table. It's just a table definition, create table, etc. With the second statement, we invoked a special function that actually distributed this table across nodes. And after the second statement, each of our existing nodes contains an empty shard of that table. And now we are going to execute the third step with which we are actually going to import data from an external CSV file into this table. And because the table is sharded, i.e. split across multiple nodes, as data is loaded, it will automatically be distributed across all nodes. That's what's going on.
Thank you. Thank you for that. Okay, and as you can see, the data is being loaded now. Thank you for that, for explaining each of the things while I walk through the exercise. So as Goran said, this is copied it, and the thing that you got to note is that when the data is being copied in, it is being redistributed.
Right.
So,
An important concept to understand is that by using any of the client tools, we always connect to the coordinator node, and that's what we communicate with. The coordinator node accepts our statements and data loads and everything, and then distributes that across all the available nodes.
and while we're doing that, let me ask you a question, Goran. So while I'm doing this, maybe you can explain. So if let's say I've done this, I've got two nodes, I haven't changed it, and then I have a huge set of data that I need to bring in again, and I'm loading data. What happens? Does it automatically get redistributed, or do I need to redistribute it again manually?
Very good. Let's take a look at the line 9 of the code. Actually, the second statement. It said, "Please distribute my table called payment users using the column user ID as the shard key." What does that mean is following. Every time when I insert a new record into the table, the coordinator node will calculate a hash of the user ID value, and based on that hash, it will decide into which shard, i.e. node, will that record be saved. So I, as a user, don't do anything after this, after executing this statement in the line 9. Everything else happens completely automatically. All inserts, updates, selects, and everything, that's what the coordinator node cares about, because it always knows where which record is saved physically on which node.
Yes. So when you're bringing in data, you don't need to do it. So it's automatic.
It's
You
automatically
only need to
taken
rebalance
care of.
if you
Or,
add a node.
yes, because when we add a new node, we are adding physically a whole new server, which is at that moment empty, and then we just need to kick the coordinator a little bit and tell it to please redistribute our data. That's it.
Yes. So thank you for that, Goran. So as you can see, I went to the shard balancer, which is under the cluster management. So you can look to see whether the data that you've just inserted into those nodes, whether it has been rebalanced or not. And as you can see here, it says rebalancing is not recommended at this time. So they do not need it to be rebalanced because, as Goran mentioned, when the data comes in, because of the statement that we ran earlier, it's automatically going to rebalance it across the shards and across the nodes.
Correct.
Okay, so I have already added a node because that was taking time. So let's go back to where I've added the node, which is the other cluster, and let's go to the resource. And yes. This is taking time. Okay, so let's go back. I have added a node. So let's go back to scale. And as you can see, we have one coordinator node, and now we have 4 worker nodes. So let's go back to the shard rebalancer.
It's calculating statistics right now, and it's
Yes.
deciding whether it should recommend a rebalancing or not.
And now it shows you that you have 4 worker nodes and 1 cluster node. And can you see the difference between what I showed you earlier and what I'm showing you now? Earlier it said rebalancing is not required. Now it says rebalancing is recommended. So we need to rebalance it so that now the data is spread across all the nodes so that the performance could be better. So let's go back. We've added the nodes. We've rechecked the balance. Now you can also run this to know whether it has been rebalanced or not. And we've done that earlier. And so now, and as I told you, we'll have the shard count, which tells you about the shard counts and the disk. If it's true, it says it's by shard count. If it's not, if it's false, it says it's by disk. Let's just run this. here. Put down here and run it. So you see, it's not doing it by shard count, and it's doing it by the disk size, because we change right now. That's the default strategy that we're using.
Right. That means that if you just kick off the rebalancing now, at the end of the rebalancing, we will have the same size of data on each shard, on each node. But that doesn't necessarily mean that we will have the same number of records on each node. That would be the other strategy, right?
That's right. And there's a different topic and a different module where they talk about sharding, and they talk about how to shard and what's the keys that you are using. We're not going to do that in this module, but there's a separate module where you can, where they talk about what to shard, how to shard, and give you more information about it. So this is more about rebalancing once you add a node. So let me go back here and let's rebalance it. And now I'm saying I want it by shard count. So let's go look at the messages. So it's executing, it's executed it. Now let's go back to the distribution and see what has happened here. Oh, wait. I need to go to
cluster.
yeah. The wrong one. Yeah.
The one with four nodes.
Yeah. So it says it's already rebalanced and it's not recommended at this point in time. So we've got it odd rebalanced. The one thing you need to remember also is that when you add nodes, you can add 20 nodes, and if you want more than that, more than 20 worker nodes, you will need to open. So the portal, you can add 20 nodes, but if you want more than 20 nodes, then you will have to open a ticket with our support team, and then it will be granted based on capacity and stuff like that. So that's something that you need to keep in mind when you're discussing or talking about your cluster and how many worker nodes it can have.
Very good.
Okay. So I think this should do it for the first requirement that they had, right? With this now, we should be able to scale and rebalance and help Woodgrove DBAs now expand and extend their application to other users as well as to other regions. So, Goran, do you think that this will help them?
I'm pretty sure, yes. That's this is enough scaling for them.
Yeah. So,
and
yeah, is it enough scaling?
I think that gives them a very good scalable platform with a distributed database that can be scaled horizontally and vertically. So considering their workload, which is basically a retail scenario, retail store that has operations in both America and Europe, so it's a pretty large user base. They have various possibilities to scale, but especially at peak times, i.e. around big holidays where the workload peaks, that's where they will probably want to add to do the scale up, vertical scaling, and then after the holiday season they can decide to scale down again.
Yeah, but you got to remember that you can scale up the CPU, and scale down the CPU, but if you scale up the storage, then you can't scale it down.
Correct. So a couple of points to remember here. Scaling CPU up and down is easy. Scaling storage is possible only upwards. We cannot scale it down. And finally, scaling RAM is not possible separately. Memory is always tied to number of cores. For worker nodes, we get 8 gigabytes of RAM for each CPU core. For the coordinator node, we get 4 gigabytes of RAM for each CPU core. That's the main points to remember here.
Yeah. Thank you, Goran. And just recapping on what we've just done, we've created a Cosmos DB for PostgreSQL database. We were able to connect to it to the shell. I also showed you how you can connect to it using Azure Data Studio. We created and distributed the table. We loaded data into the table. We were able to show you how to balance it and also to see whether your data has been rebalanced or not. We were able to add a worker node. We checked to see whether it was rebalanced. We rebalanced it, and then we showed you how it was rebalanced, and the fact that once you rebalance it, you don't need to rebalance it again. So having said that, I think we've met the first requirement. So let's go with the second one and see what the second requirement is. So the second requirement is they want to have the ability to offload their read-only and their reporting and their analytics piece of it to the European corporate offices. So Goran, what do you suggest we do? How do we help them meet this particular requirement that they have?
Right. In such a scenario, we usually aim to provide a read-only copy of the database because it's good enough for generating reports and analyzing the data. Such a copy or replica doesn't require any read-write operations, so it's enough to be readable. How do we do that? We simply activate the replication that's natively available at Postgres database, but here in the context of an Azure database as a service, it allows us to apply this replication across cloud regions. And in fact, it's pretty straightforward operation. All we need to do is to go to the Azure portal and add one or more replica in selected Azure regions. As soon as we hit the save button, what happens behind the scenes is new instances of the server with the same configuration are deployed in selected regions, and the data is automatically replicated across. Geraldine?
Yeah, so the question I have is, so if I want a read replica, I just cannot add another node to the existing primary cluster and say, oh, I want this as a read replica only, right? That will not work.
Correct. That's a typical question every time when we speak about clusters. Clusters are generally a group of servers that work together. However, there's generally two types of cluster architectures. One architecture means replicating the data between cluster nodes, in which case each node is identical to others. That's one type of clusters. The type of clusters that we are talking about here is different in that the data is distributed or sharded within one cluster, which means that nodes contain different data. There are no two nodes that are identical. Therefore, we cannot have one of nodes containing all data just for read-only purposes. What we can do is we can replicate the entire cluster into an exact copy of that entire cluster. That's what's happening here, which means we have one cluster, we have loaded our data, we have designed perfect sharding, everything was fine, and now we need a read-only replica. In that case, we will create an exact copy of the entire cluster, and the data will be replicated across. Obviously, we are doubling the amount of hardware,
that's right,
of resources, and we are doubling the cost.
So right. The read-only replica is now also going to be like the primary. It's going to have its own coordinator node, and it's going to have its 3 worker nodes or the 2 worker nodes or however many it needs, right? Does it need to be identical to the primary cluster, or can it have its own environment?
So the size and the configuration of the new replica server is inherited from the original server, which means it will have the exact same number of nodes, the same configuration, the same everything. However, there's a couple of things that are not necessarily identical. First of all, it's another server, so it's got a different name, and it's got its own firewall rules, and server configuration parameters can be different.
Well, that makes
However,
sense.
it will all be configured after the initial creation of the server.
Okay. So that kind of makes sense, right? To have its own firewall rules because it's going to be probably in another region and another
Yes.
location also. So how many replicas can we have, and can we have replicas in different regions?
We can have replicas in different regions, but there will be maximum of 5 replicas in total. Please keep
Not per region. Okay.
this number in mind. So the total number of replicas will be 5 at maximum. And one more aspect to remember: the replication will be asynchronous. It will not be synchronous. These replicas will not always have identical data. The read-only replicas will always have a certain lag compared to the primary replica. The lag depends on several factors, obviously, like the physical distance, the amount of transactions, the amount of data, etc., etc.
Okay, so, so one of the points that to note is that while you can change the firewall rules and the parameters and stuff like that, the storage size and of the worker nodes is inherited from the primary cluster, and that cannot be changed. But you
Correct.
can, however, change the other rules and the parameters for the secondary or the read-only replicas.
Correct.
Okay.
And that's really the entire theory. I am going to show how such a configuration looks like in a hands-on scenario.
Yeah.
So
Go ahead with the demo, Gaurav, and
I'm
maybe
going.
you can share your screen.
Yes, here's my screen. Prior to this session, I have prepared several instances with various configuration. I will start with this one, which is just freshly created cluster with 2 worker nodes, just as we saw previously in Geraldine's presentation. I didn't make any further changes whatsoever. And now the first thing that I'm going to do is to activate the replication. For that, I will look for the replication in the left-hand menu. Here it is, replicate data globally. And this is my favorite screen. It shows a world map showing points which represent locations. We call them Azure Cloud regions in the world where that we can choose as targets of our application. So let's do something simple. You will see, because I'm based in Europe, my primary replica is located in West Europe, which is actually Amsterdam, Netherlands, physical location. So now I'm going to replicate to my database to another European region. Let me choose a server name first, actually cluster name to be precise. I will call it like this. Subscription resource group, it's all automatically filled. And then here under location, I will choose the other European region, which we call North Europe, and physically it's Ireland. If you're curious, you will see that the configuration is automatically taken from my primary replica, and I cannot change it here. So I'm going to hit the OK button now, and that's all I need to do. At this moment, a new deployment is starting, similar to deployment that Geraldine executed previously. And what this means is nothing else but provisioning in another copy of my cluster in another region. As soon as the cluster is provisioned and is online, the replication will start, and all the data that I have in my primary cluster will be copied across to the secondary replica, which will be available as a read-only server or cluster, right? Better to say cluster. Now, it will take a couple of minutes to finish that. We don't need to wait for it. If I just take another look at my primary cluster, let's focus on this one. This is the endpoint that I use to connect to. This is nothing else but a network name of my cluster, or server name, if you will. If I connect to this, I am connecting to my primary cluster, which is rewritable. I can read and write in this one. But if I connect to the replica that's got its own endpoint, I will only be able to execute read-only queries, select, and similar things. That's it. Let's take a quick look at the replica data globally. You will see here a symbol. It says read region, the dark blue one, but that one is not yet online. It says status provisioning, and you'll see the type of clusters. The primary is read-writable, the secondary is readable only, and the configurations are same. At this point, I can keep adding replicas up to, how many did you say? 5 in total. You will need this later. Right. So I can keep adding them, and I can delete them from this configuration at any time. It's simple as clicking at this button, which is now disabled because the replica is not online yet. But when the provisioning is finished, then I can decide to delete it again. That's all, really.
Okay.
Are there any questions from the audience, perhaps?
Yes. So there is one. Is it possible to, I can see the one that is it possible to do a synchronous replication to a nearby location or to some data center in a different region? I'm assuming that's a region.
Probably.
Rajay.
Yeah. Let's check. There you go. So you see my primary replica is in West Europe. And I'm going to try and create another replica in the same region. West Europe. Okay, it's accepted. So the answer is yes. I see another question. It says, how do you use Azure? Not
Oh,
region,
it's
it's
raw.
rack
Oh,
under same.
it's rack.
It's same
I read it as
data
raw. So,
center.
oh,
Right,
not region, it's rack under the same data center.
right. That's actually what we are doing right now. When as soon as I selected the West Europe as a target for my replica, it will create a replica in the same data center. There's something else related to that we'll talk in the third part of this presentation, so please stay with us.
Yeah.
And because there's a question that sounds like a newbie question, how do you use Azure? Let me try to answer that in a simplest possible way. Azure is a public cloud service, which means you go to the site called portal.azure.com. You need to register, obviously. You get your account for it. When you get your account, you're able to log in. You get one or more subscriptions, which is just a mean for billing. And as soon as you have that, obviously you provide your billing, information, payments, credit cards, whatsoever. And from that point on, you are able to go ahead and use any types of cloud resources that you need. Cloud resources mean, just simply put, any of these things: database, applications, blockchain, virtual machines, whatever you need. So this is kind of your own data center that you can start using immediately without needing to buy any hardware or anything else. I hope this answers your question.
And maybe I'll make one more point to that. If
Yes.
you're a newbie and you don't have a subscription, the Learn modules, as far as I know, they have a sandbox where they give you like a test subscription. Try that out and let us know if it works or not. And if it doesn't, I can find out. But we do have a sandbox and for the Learn modules. So if you do not have a subscription, just give that a shot and let us know how it works out.
Correct.
Okay.
All
I think that's
right.
all we had in the section. And yeah, I think we're good on time. We have like 20 minutes more.
Yes.
So I'm not going to take much time. I think I'll need to take 10 minutes for the next topic, and then we can open it up for questions, or we can have the poll. So we're done with the two business requirements. I think they're going to be happy with us because we can obviously use read replicas to offload and do analysis, and it's not going to interfere with the read write application. But the other thing that's really crucial and important, especially for a payment application, which is mission critical, is the fact that it needs to be highly available at any time or at all times, right? So the good news is that Cosmos DB for PostgreSQL allows you or supports high availability. Now, they have implicit high availability. So there are two things here. One is, if you know single server, if you've been on single server, we have high availability, but it's only at the storage level, right? So you have local redundant LRS, and along with the storage, you get 3 copies. So if one is down, they immediately spin up another. So you have 3 copies at the storage level, and that's what is your implicit high availability. But we also give you the option of having high availability at all levels for your application. So what does that mean? What it means is that you are going to have a complete replica of your primary. If I have a coordinator node with 2 worker nodes, you're going to have the same standby with a standby coordinator node and 2 worker nodes, so that in case one of the nodes goes down, automatically it will move over to the standby replica. So that's an automatic failover. Now, as you know, like Goran mentioned, with the read replicas, the streaming is synchronous, asynchronous, so there's a latency. Whereas for a standby replica, it is synchronous replication. So all your data that you have in the primary is replicated over to the secondary synchronously. So it's always available there. So then you may ask me, then why is failover, failover is automatic, but you don't have to do it manually, but why? Why is it taking time? So that's because there will be a little downtime when you're trying to promote and make these standby your primary cluster. So in that moment where it's promoting it to the primary cluster, that's where you're going to have a few glitches, right? And that's where your application should be should be able to connect or reconnect and have a retry logic. So if it gets a failure, it should try to retry it and see. And then once it comes up, it will be able to connect to it. You don't need to change any connection strings. You don't need to do anything. All you need to be worried about is, do I have retry logic? In case it fails, what should I do? You try to reconnect again, and then as soon as the standby gets promoted to the primary, it will automatically connect. Again, it gets provisioned in a different availability zone, and you can see what the availability zone is, what the high availability status is. You can find all that in the portal. It's available there. So if you want to see, is my cluster now, what's the condition, is it available, where is it, like what's the status of my the high availability, you can check it out in the portal. And when we're talking about availability zones also, just make sure that you go and look at the documentation to see which regions have the availability zones already scheduled, which regions have availability zones, because some of the regions do not have. So just go and check it to see whether it's available or not. And as I said, this is really important. Your application needs to have that retry logic so that it can connect to the new standby. So you may ask me a question, okay, if you've gone to you've made my standby, now my primary, what happens? Do I have a standby again, right? And yes, you do. So what happens as soon as the standby gets promoted to the primary cluster, immediately, as soon as that's done, then they start provisioning the next standby, so that becomes available, and then the data is synced over.
Correct.
So there are different stages. So you may ask me like, okay, the failover, how does the failover happen? So Goran, do you want to talk about how do we know when the failover takes place, or how does the failover take place?
Yes. First of all, and very important to understand the concept, because I'm looking at the questions that are coming in the chat. We are going to answer these questions in a moment. Trust us. And related to that, an important point to understand is that all these databases are databases as service, which means you as the end user, you don't have full control of them, in the sense that you don't need to install anything. You don't need to set up hardware. You don't need to set up operating system. You don't need to patch anything. That's what the platform does for you. And because the platform does that for you, there must be some small downtime sometimes, right? If there is a patching or security updates or upgrading to the latest version or whatever else, it will always be executed on one of the copies of your databases, and then there will be a switchover or um, or a failover, if you will, and then your database will be continue to will continue to work. During this short time, you might experience a short connection loss. That's absolutely normal in any real case scenario. It's not only limited to cloud. It's basically the same thing that happens in your own data centers if you need to execute any patching. So because of all that, and because of the failover scenarios, the applications should always be implement the retry logic. Now, how does this all work? How does the platform behind this knows when to execute a failover? It knows because there are monitoring processes that execute health checks on your database nodes all the time. Health checks means that the database is online, that there is no errors, that the storage is accessible at not I don't know, corrupt or something. If all is green, then no problem. If there are any failures, any type of failures in hardware or software or hosting your database, then the database node, in this case we are talking about nodes in the cluster, the node will be declared as unhealthy and down. If that happens, that's where the platform decides to execute a failover at the node level. So each node is one complete server. If it's unhealthy, it will be failed over. Now this failover takes up to a couple of minutes, depending on the size and the transactions and whatever action needs to be taken. When that failover is ready, then the full database recovery is executed and the node comes online again. So these are the phases in this process.
Thank you, Goran, for that. So once it fails over, once it recovers, once you have the full recovery, and these are the recovery availability recovery stages that you can see through the portal, so you know what's going on. And also, once it fails over, I know someone has asked the question about HA and DR, and I want to be very clear, we are only talking high availability here because the concept is different between high availability and DR. And I think Inder has done a great job in distinguishing between high availability and disaster recovery. So going back to the high availability states, one is as Goran has explained, we have the recovery stages, which is different from the availability stages, right? The availability, and for those of you who have all worked with high availability in other technologies also, you'll know that it's not very different here. It's the concept is the same. Maybe the terminology may be a little different, but the concept is still the same.
Right.
If it's no, it says your high availability isn't enabled, which means that you only have implicit. And if it is healthy, it says the node is fully replicated to its standby. If a failover is in progress, it's telling you it detected a failover, and now we're trying to promote the standby to become the primary. Then it says creating standby, so it's telling you this is what I'm trying to do. And replication in progress is saying, okay, the new standby is ready, it's synchronizing with the primary, and as soon as it's done, then you're ready to continue and it's fully recovered. So these are the different high availability states that you have. And the thing that you need to remember is failover doesn't happen immediately. It does not happen as soon as the node goes down or there's a little delay. And we don't want that to happen because you want it to wait to be sure whether the node is really down or not. So only after the fourth failure that you get, then it's going to start or indicate that the node is down and it's going to fail over and it's going to start to fail over. Do you want to add anything to it, Goran?
I think you put it perfectly. I would just like to use the remaining 9-ish minutes to show that in action.
Yes.
So I'd like to show my screen right now. There we go. Let me just continue or show the final result of our previous exercise where we activated the global data replication to across 3 regions. You remember we started with West Europe, that's our primary cluster. Then we initiated the replication to the North Europe, which is now online, available. And then we created another replica in the same region, again with West Europe. It's online, it's readable, and now I have 3 exact copies of my cluster. 3, each of them having 3 nodes, so we have 9 nodes in total running and replicating data amongst themselves. Now, related to one of the questions about replicating to the same rack or same data center, and related to the HA story that we just heard, we probably it's probably worth mentioning the following point. We mentioned something called availability zone several times. Now, this is the time to explain what it is. The structure of the cloud is follows. First of all, it's split across so-called regions. Each region is one physical location where our data centers are. When you zoom into any of these particular regions, let's say West Europe, it's a physical location, but it consists of multiple data centers. That's physical, premises or buildings that are closely located to each other, but they are still physically separate data centers connected with very high speed network lines. Within these data centers, we have something that we call availability zones. That's further, split within a data center. An availability zone is a set of servers that can operate as a separate unit. So you can imagine a data center having multiple availability zones. Why? Because of high availability. You want to have your replicas, you want to have a cluster, high availability cluster that replicates data between 2 instances. It makes sense to put one instance into one zone and the other instance into another zone. Why? Because each of these zones are independent of each other in terms of network cabling, electricity, cooling, etc., etc., etc. So if it happens that there is a hardware failure that brings down the entire availability zone, then there will be other availability zones with the actually identical copy of your data. So that's the additional level of security. And now how do we use that for the high availability? Let me show you. I'll take again this server that doesn't have any high availability yet. I will go to, oh, by the way, when we look at the overview screen right here, and we scroll down, you will see the structure. There's one coordinator nodes and 2 worker nodes. And then it says high availability, no. And this is the physical location of my server. It's physically located in the availability zone number 1. Now, if you look at the replica that we put in the same region, you remember, it is replicating in the same region, but it was deliberately physically put into availability zone 3. It doesn't make sense for you to replicate in the same availability zone. There's just no need for it. You don't have any disadvantages from this configuration. You only have advantages from it. So going back to our server, this one, I want to activate high availability for it. All I need to do for it is tick this box, and if I wish, I can decide into which availability zone I want to replicate, to put the second server. Yeah. Because my primary server is in the availability zone 1, let's say I want my high availability replica to be in the zone 2. Now, that's it. As soon as I clicked OK, what started in the behind the scenes is a provisioning, or if you want, deployment of an identical copy of my cluster in the availability zone 2. And as soon as the cluster is online, the data will be replicated across. When this replication is online, it will be synchronous. It is not asynchronous anymore. So let me take a look at the questions.
Okay, so one point that I'd like to also mention is that when the failover happens, like we said, your node gets moved to a different availability zone. Let's say your app is still in the previous availability zone. So the one thing that you need to remember is that when we do the maintenance, we bring them all back together so that they will be co-located with your application again. That's just one point I wanted to emphasize on.
Correct. All right, this deployment takes a while, but because of that, I have another server that I prepared previously. It should be this 31, I believe. No, 31, but the first one, 30. Here is it. You see, I have activated high availability previously. And when I look at the description of my server, it will say high availability activated, and it's in status healthy, healthy, healthy. And the server is in the availability zone 2. That's it. That's all you need to do. It automatically creates another copy of your server in another availability zone. It automatically synchronizes the data, and it automatically brings you the failover possibility. The only thing that you need to pay attention to is this doubles your hardware resources, and this doubles the cost at the same time. Okay.
So I see a question in here. I don't know if it was answered or not, but how can we do synchronous replication? So I'm assuming you're asking about synchronous replication in the terms of read-only replicas and not for high availability, right? Because for high availability, it is synchronous replication. So when you talk about read replicas, the question I would ask is, why would you need to have synchronous replication? If you want to have synchronous replication, you have the high availability, and then you use because with the read replicas, you do not want, the reason why you have read replicas is because you do not want the performance of your write application to degrade, and that's the reason why you have read, and that's why you have asynchronous replication. Goran, do you want to quickly talk to that, and then we'll go to the...
Yes, just very briefly, synchronously replicating data sounds very cool. However, it's very risky for performance of your operational applications, because every time you start a transaction, it will stay open until all the replicas are synchronized. That's why you want to reduce that to a necessary minimum. If you want to have synchronous replication for high availability purposes, that's what this HA option does. If you want to have a replication for read-only purposes, then you don't want synchronous replication for that, especially not across regions.
And we are at time, but let's go quickly and go to the
Yes.
the questions.
Data loss is actually the
Yes.
point of high availability. Wait, is that Maya?
You are sharing. Continue sharing it. Oh, you're not?
Nope.
Okay.
Wait.
Can you see my screen? I have. So the IT department at Woodgrove Bank noticed performance issues with the app. They suggested increasing the RAM. Which of the options can help with their request? If you can post this aka.ms/polls in the chat, maybe we can get some answers from there.
Okay, MS polls.
Do we get the? Can you see the response page, Goran?
Can
I go to the next
yes.
question. All right. We're going to the next question.
I think you're sharing the screen now.
Yeah. Yeah. So the answer is it scales the vCores. When you scale the vCores, then your RAM automatically gets scaled. Let's go to the next one. The high availability is enabled on the Woodgrove Bank cluster. One of the worker nodes is experiencing issues based on the information. When should you expect the node to fail over? Immediately on the error, after the fourth failed health check, or when the whole cluster fails?
So is anybody participating in the online poll?
I'm not sure.
If not, you can type your answers
After
in the
the
chat as well.
fourth failed health check. And let's go to the last one. How many read replicas can Woodgrove Bank have? 5 read replicas per region, as many as you need, there's no limit, or 5 read replicas in total. So you can have only 5 read replicas in total, it's not per region. And with that, I think, I hope you now know where to use scale and rebalance and how to rebalance it, when to use adding a read replica, and whether it would need synchronous or asynchronous replication, and what is high availability and when to use it. So thank you all for your time here, and thank you for joining us.
Thank you very much. Bye-bye.
Bye, everyone.